let us see this problem. We are given a string. We need to find out longest substring of the string which has all distinct characters. When we say substring, we mean consecutive characters. Subsequence means the characters may not be consecutive, but in case of substring, they have to be consecutive. Let's take this example. We have a string ABCD, ABC, and the substring, the longest substring, which has all distinct characters, is CDAB. So our answer is 4. Let us see this example. Here we have all same characters, so our output is 1. We have only one length longest substring which has all distinct characters. We can either pick this or this or this. In fact, in this example, we could take this substring also. This is of length 4 as well and has 4 distinct characters. Let us see this example. In this string, the maximum length substring that has all distinct characters is of length 4. This is also a possible answer. We can consider this string also as an answer with all distinct characters. Please note that if you take any other substring, either this substring will have duplicate characters or it will be of a smaller length than 4. For example, if you take AB, it has all distinct characters but length less than 4. If you take ABA, it has duplicate characters. So we need to find out longest substring with all distinct characters. Now please pause this video and try to write down a solution that takes a string as an argument and returns length of the longest substring with all distinct characters. We are going to talk about 3 solutions for this problem. One is big O of n cube, then the second solution big O of n square, then third solution big O of n. Let us first talk about a naive solution to solve this problem. Let's say we have this string ABAC. What we do is we consider all substrings of the string. First we consider all substrings that begin with A. The substrings beginning with A are A, AB, ABA and ABAC. For every substring, we check if it has distinct characters or not. For checking, we have written a separate function rDistinct that takes a starting index and an ending index, and it checks whether the string from index I to index j has all distinct characters or not. How does it check? It makes a visited array, Boolean visited array here. We have written this syntax in Java and this in C++. And whenever it visits a character from this index to this index, and if this character is already visited, it returns false immediately. Otherwise, it marks this character as true. So this is simple rDistinct function, and time complexity of this function is big O of n, where n is the total number of characters in the string. So this is a big O of n function that we have written here. Now what are we doing? We are generating all these substrings. And how are we generating the substrings? We fix the start index as I, we fix the end index as j, we consider the substring from I to j, we check if this substring has all distinct characters or not. If this substring has all distinct characters, we compare the current result with j minus I plus 1, where j is the ending index and I is the starting index. So our first substring is this one, and for this one I is 0 and j is 0, and our result will be initially 0. So when we enter here first, we update the result as 1. Then we come here, AB is the next string, I is 0 and j is 1. And we update the result as 2. When we come here, we notice that it does not have all characters distinct, so we do not go inside this if condition. When we come here, we again notice that it does not have all distinct characters, so we do not go inside this if condition. When we come to B, we go inside this if condition, but result is already 2 here, so we do not update the result. For BA, again result is already 2, so we do not update. For BAC, we go inside this if condition because rDistinct is going to be true here, and we are going to update the result from 2 to 3. Now we are going to come to A, for which we are not going to update the result. For AC also we are not going to update. For C also we are not going to update. So by the end of this function, we will have our result as 3 for this string BAC. Let us now talk about time complexity of the solution. In this solution, we have 2 loops, I equal to 0 to n minus 1, j equal to I to n minus 1. Inside these 2 loops, we call a function rDistinct, which has time complexity as big O of n. So our overall time complexity is big O of n cube. Now please pause this video and think of an approach which is better than big O of n cube. We are going to talk about two more solutions. One is big O of n square and one is big O of n. Let us now talk about a better solution. Time complexity of the solution is big O of n square. In this solution also, we consider all substrings. We run two loops, 0 to n minus 1 and I to n minus 1. We consider the substring from I to j and check if it has all the characters distinct or not. In the naive solution, we were calling a function r distinct which was traversing through every character from I to j to check if all these characters are distinct or not. Here what we are doing is, for every value of I, we are using one visited array rather than using one visited array for every substring. Because when you fix an I, what you do is you keep on adding characters, right? So your I say is initially 0. So you are initially, j is also 0. So this character is your initial character or this is your initial substring. Then you extend and add b. So you need to add b also to your visited array. Then you add a. When you try to add a, you see that this is a repeating character. You simply break the loop, right? You do not proceed further. So you basically are not going to consider a, b, a, c. That is what we did in the naive solution as well. When we come to b, we create a new visited array. So when we are adding a character for the current starting point or the current I, we simply mark it as true. And if it is already marked as true, we break the loop. And when it is not marked as true, it means it's a different character and all the previous characters must also have been different, right? Otherwise we would have broken the loop. In those cases, what we do is we compare the current result with the length of current substring. And if the length of current substring is greater, we update the result. And at the end, we finally return the result. So this is a better solution. Now please pause this video and think of a solution that is big O of n, even better than this. Let us now talk about an efficient solution to solve this problem. The idea is to compute this value max and j for every index j, where max and j is length of the longest substring that has all distinct characters and this substring ends at index j. Let's see with this example. We have the string ABC, A, B, B, D. Longest substring that ends with A and has all distinct characters is 1. For first character, it's always going to be 1. Longest substring that ends with B and has all distinct characters is AB. For C, it's ABC. For A, this is BCA. For D, this is BCAD. The string must end with this index and should have all the distinct characters. For B, the string is CADB. For D, the string is BD. So if I compute all these values for every index, I simply need to return maximum of all these values at the end. So our result is maximum of max and j, where j goes from 0 to n minus 1. So we are saying that this solution is going to be big O of n, and we are going to compute max end for every index from left to right. So this max end for the current index should be computable in the constant time. How do we compute this in constant time? The idea is to use the previous value of it. So if you are at index j, you can use max end j minus 1 to compute max end j. Max end j minus 1 is the length of the longest substring that ends with index j minus 1 and begins at some index I. How do I use this length to find out max end j? See, if this character xj does not appear in this string at all, in this string from xi to xj minus 1, then my result will be max end j minus 1 plus 1. If strj is not present in the string max end j minus 1, right, in this string from I to j minus 1. If it is present in this string, then it will be from that index to xj. And what will be that index? That index will be previous index of the character xj. The index at which this character xj appeared just before this occurrence at index j. So if I somehow get this index in constant time, I can do j minus previous of strj plus 1 to get the length of the longest substring that ends with j if this strj or xj appears somewhere from I to j minus 1, where I to j minus 1 is the longest substring that ends with index j minus 1. Now the question arises, how can we figure out if this character strj was present in this string from I to j minus 1 or not? For this purpose, we can again use our previous of strj. If previous of strj was less than I, then this was not present in the previous this string, otherwise it was present. So we use this previous of strj for two purposes, and previous of strj for every character can be computed and can be obtained in big O of one time. We just need to use the character as an index in a previous array, and whenever we find the character, we update its index in the previous array as a previous index. Now please pause this video and try to write down complete code that takes a string, returns the length of the longest substring with all distinct characters in big O of n time. Let us now see implementation of the efficient approach. We traverse the input string from j equal to 0 to n minus 1. Every character at index j is considered as the last character of the substring. We find out length of the longest substring that ends with j and has all distinct characters. We call it maxend. So we are going to compute maxend for every index j, and we are going to compare it with the result. If result is smaller than maxend, then we are going to make the result as maxend. We simply take the maximum of result and maxend. Let's see this example. Max end for this index is 1. Max end for this index is 2 because there are two distinct characters. Max end for this is 3. Max end for this is also 3 because there are three distinct characters in the longest substring that ends with this A. Max end for D is 4. Max end for B is again 4. Max end for this last D is 2 because there are two characters that end with D and have all distinct characters. So we compute maxend and we take the maximum of all the maxends. To compute the maxend, we need starting index and we need the ending index. We already have ending index as j. Now the question arises, how do we compute the starting index? To compute the starting index of current window, we use two values. One value is previous starting index that we did for the previous window for index j minus 1. Right? We run from j equal to 0 to n minus 1. So when we are at current j, we must be having starting index for j minus 1. The other value that we use here is previous index of strj. strj is the character that we are currently adding to this window. We find out when did this appear last. If it appeared before the starting index or at the starting index of the previous window, then we need to extend the previous window. Otherwise, we need to keep the previous window as it is. Let's understand this with this example. We have the string ABC, ADB, D. We initialize previous of every character as minus 1. We initialize starting index as 0, initialize result as 0. We begin with this character. For this character, starting and ending, both indexes are 0. So we compute our maxend as j minus I plus 1, which is 1. Now we compare it with the result. Result is 0, so we get a greater value. So we update the result as 1. We mark the previous of A as 0. Now we go to the next character, j is 1 now, and we compute this value, previous of this character, and we compare it with the previous starting index. So previous for every character is minus 1, so it's minus 1 for this also. So starting index that we are getting is minus 1 plus 0, so we get the value as 0. And starting index, current starting index is also 0, so we get the starting index as 0. Now we do j minus I plus 1, we get the max end as 2. So we get the length as 2 for this index, right? And we compare it with the result. It's greater than result, so we update the result and we update the previous of B. Now we come to C. When we come to C, we again do the same thing. We compare, we find out the previous index of C. C was not there at all. So previous of C will be minus 1. Minus 1 plus 1 will be 0. If we take the maximum of 0 and 0, we'll get 0. So we are going to get the starting index again as 0. So length of the longest substring that ends with C is 2 minus 0 plus 1. So we get the length as 3. And this is greater than result. So we update the result. and we update previous of C also. Now we come to A, and this is where we get an interesting case. Starting index of the previous window is 0, but previous of A is also 0. So we get 0 plus 1 here. So this window for this character has to start from 0 plus 1. We are taking the maximum of two values. So we get the starting index as 1. We have J as 3. We get the length as 3. Right? So for J equal to 3 for this character, we have the max ending as 3. It's not greater than result, so result is going to be 3 only. We update the previous of A. Now we come to D. D did not appear at all. Previous of D will be -1. So you will not be changing the starting index of previous window. You will be keeping it as it is, B only. And you will find the max end as 4. 4 minus 1 plus 1. You will update the result and you will mark the previous of D as 4. Now we come to B, and this is again an interesting case. B has appeared before. So your starting index will change to C. Now, right? How did this change to C? We got the previous of B as 1. We add 1 to it, we get 2, which is greater than the starting index of previous window. Starting index of previous window was 1, and now we are getting 2. So this is our new starting index for this. So what is the length we get? We get the max end as 4 now, which is not greater than the result, so we do not update the result. We update the previous of B as 5. Now we come to this index, and for this index, we compute the previous of D. Previous of D is 0, 1, 2, 3, 4, 5. We have already computed it here. Now we come to the last index, and we compute the previous of this character D, and we get the previous of D as 4. So we use previous of D plus 1, which is 5. So we get the starting index as 5. Please note that we are taking this value because starting index of the previous window, the previous I was this index, right? And this index is definitely greater, so we are taking it 5. And the max end that we are going to get is this one, 2. 6 minus 5 plus 1. And this is definitely not greater than result, so we are going to keep the result as 4, and we are going to update the previous of D as 6. So this is how this algorithm works. It gives you the result 4 for the string, which is your final answer. You have multiple strings of distinct characters with length 4. These are the multiple answers we can get here. Let us now analyze time complexity of the solution. We are simply running a loop, and inside this loop, we are simply doing indexing in the string, which is big O of 1 operation. So overall, time complexity of the solution is big O of n. We have talked about 3 solutions for this problem. One is big O of n cube, then big O of n square, then big O of n solution.